Hello everyone and welcome to this new video where I'm going to be taking up a problem from the International Youth Mathematics Challenge 2025. This is a question from the qualifier round. You are given 5 questions and you have to score a certain amount of marks according to your age group to qualify for the next round. Each question carrying 5 marks. So this is one of the questions from that qualifier round. A very basic question from number theory, but it'll still teach a lot. So I would request you all to first give it a try and then look at the solution so that you can learn a lot more from this solution. So let's begin. Let's see the question. We have to prove that for every positive integer n, the number n to the power 4 plus 4 is a composite number except for one value of n. Now, if you were thinking where to start from, how to start, what to do, what not to do, think of the simplest example. Positive integer n is basically a natural number, and the smallest natural number is 1. So let's first assume y to be n to the power 4 plus 4. And if you observe at n is equal to 1, y is equal to 5, which is a prime and not a composite number. And if you notice at the second part of the question, except for one value of n. So I think we have got a value of n for which y is not a composite number. But we still have to prove that n is equal to 1 is the only value of n for which y won't be a composite number. So there might be various methods to do it. I thought of this method, which I find pretty easy, not too much of concepts being used. So what I am going to do here is that we basically have to prove that for every value of every natural number n which is greater than 1, basically 2, 3, 4, 5, 6, and so on, this number y will be a composite number. So let's take two cases when n is odd and when n is even. So let's take n as even as the first case. When n is even, so suppose it's in the form of 2k, where k is another positive integer. So basically 2, 4, 6, 8, 10, 12, and so on. Let's put in the value of n from here in y. So this becomes 16k to the power 4 plus 4, which is 4 times 4 to the power k plus k to the power 4 plus 1. Clearly, we have a factor of 4 here, which means this number will be divisible by 2 and 4 always. So that means for every even number, for every even positive integer n to the power 4 plus 4 will be a composite number. So now let's look at the second case when n is equal to 2k plus 1, where k is again a positive integer. So we are looking at values of n as 3, 5, 7, 9, 11, and so on. We have already seen the case of n is equal to 1 over here, where we got a prime number. So now we'll hope to see that in this second case, we get y as a composite number like we did in the first case. So now just simply put the value of 2k plus 1, in fact put the value of n in y. So let's simplify this. I can write this as 2k plus 1 whole square plus 2 whole square minus 4 times 2k plus 1 whole square. Well, I have done nothing. I have just used the identity of a plus b whole square is equal to a square plus b square plus 2ab. And I have just rearranged the terms. Now, let's further simplify it. We'll be using the identity of a square minus b square is equal to a plus b into a minus b. So this whole thing is a, this whole thing is b. Basically, in fact, I'll write it here so that it's more clear. Here a is equal to 2k plus 1 whole square plus 2, and b is equal to 2 times 2k plus 1. Now let's use the identity. From here we get a plus b times a minus b. Let's further simplify it. So here I see a term of 4k square and 8k, because 4k over here and 4k over here, and 1 plus 2 plus 2, which is 5. And here you see that the terms with k gets cancelled, so we'll be left with 4k square plus 1. Now we have gotten this, and now let's think about it in this way. For y to be composite, it shouldn't be a prime. Well, proving this number to be composite is not looking very good. But if you prove it, if you prove that it is not a prime, it will be a composite number. So let's think it in that way. For this y to be a prime number, either this will be a prime and this will be 1, or this will be prime and this will be 1. Let's consider both the cases. When 4k square plus 1 is prime, in fact, when 4k square plus 1 is equal to 1, we are taking this case first. So 4k square plus 1 is equal to 1 simply implies that k is equal to 0, which kind of contradicts our statement because initially we said that k is a positive integer. So this case is rejected. Now let's look at this case when 4k square plus 1 is prime and 4k square plus 8k plus 5 is 1. So when 4k square plus 8k plus 5 is equal to 1, basically means that 4k square plus 8k plus 4 is equal to 0. K square plus 2k plus 1 plus 2, in fact, sorry, plus 1 is equal to 0. This is basically a plus b whole square. So I can write this as k plus 1 whole square, and we get the value of k as minus 1. Again, k is a positive integer, so this case is also rejected, which means that this number cannot be a prime number when k is a positive integer. This implies that this number 4k square plus 8k plus 5 times 4k square plus 1 is also a composite number. So what all have we concluded from here? That for all odd numbers, except 1 and for all even numbers, n to the power 4 plus 4, which we consider to be y, is composite. And I think we are done with the problem because that's what it was asking, right? So, a very basic solution. I didn't use a lot of concepts, just basic algebra and odd and even numbers concept, which everyone is aware of. So, a pretty simple question, as I said, but I hope it taught you a lot. If you weren't able to solve the problem, I hope you enjoyed this solution, and I'll meet you in the next video.